the hi again. I want to introduce the new like the rest of the problems. Here I have two closed loops. A and C are close to a long wire carrying a current I as in the figure. Find the direction clockwise or counterclockwise of the current induced in each loop if I is steadily decreasing. While I is decreasing, what is the direction of the net force that the wire exerts on each loop? Explain how you obtain your answer. Again, this is similar to what we did in the previous question. Here we have the current going in this direction. This is the, I will say first, the rectangular loop, which is C. And I know that the current is decreasing, then induce should help increase the flux because the flux is decreasing because of the current decreasing. Therefore, B original and B induced, they should be in the same direction. Now for the electric wire, here it is going using the right hand rule, going out of the page and here into the page, and then on top B induced should be the same as original, then counterclockwise, again using the right hand rule. Below the wire, we know that it is below the wire below is the wire, just 1 second, okay, below the wire we have the the loop A, and therefore I will say that this is really a cross, means it is into the page, and then I will say because it is into the page, then I will say the B induced should be in the same direction also, and therefore I will say the current, it should be clockwise. All right, now I will say here that the second part, why I is decreasing, what is the direction of the net force that the wire exerts on each loop? Explain how you obtain your answer. And I will say both of them, they will be pulled toward the long wire because the current is decreasing, and because the current is decreasing, then I will say the flux is decreasing, and therefore I will say that since the flux is decreasing, we know that this should be attraction. Now the next one, it is using Lenz's law, determine the direction of the current in resistor AB of the figure when A switch S is opened after having been closed for several minutes. Coil B is brought closer to coil A with the switch closed, and the resistance of R is decreased while the switch remains closed. Here also we are going to work with what is the B original, what's the B induced, depending on if the, I will say the flux is decreasing or increasing. And here I will say in the first part the switch is open and therefore we're going to have decrease in flux, then both the induced and the original, they should be on the same direction. I did use the right hand rule here to find what is the direction of the magnetic field, the original magnetic field. You will use your fingers curled in the direction of the current, and then your thumb is going to point towards the north, and then I will say the other one should be in the same direction, and then again you are going to use the the same rule and I will say right hand rule to find what is really the direction of the current. Now, bringing B towards A means that we are going to have an increase in the flux. Then I will say if B original again is going to stay in the to the right, then the B induced should be to the left, and therefore the current from B to A. The last one, decrease in decrease in R, means the current increases and therefore the flux is increasing, and then again the both B's, they're gonna be opposite directions, and then the current is gonna be from B to A. All right, I'm gonna stop here, and I will move to another video in